Moving on to the fourth problem. Find the zero of the polynomial in each of the following cases. So the first polynomial is p of x is equal to x plus 5. And the second one is p of x is equal to x minus 5. Third one is p of x is equal to 2x plus 5. So in order to find the zero of the polynomial, we need to equate the given polynomial p of x is equal to 0. So if we equate p of x is equal to 0, we can find the value of x, which is nothing but the zero of the polynomial. So let us see the first bit, which is p of x is equal to x plus 5. The given polynomial p of x is equal to x plus 5 must be equated to 0. That becomes p of x is equal to x plus 5 is equal to 0. X plus 5 is equal to 0. So transposing plus 5 to right hand side, we get x is equal to 0 minus 5, which is minus 5. That means x is equal to minus 5, which is nothing but the zero of the polynomial. Now let us see the second polynomial, which is p of x is equal to x minus 5. So for finding the zero of the polynomial, we must equate the given polynomial to 0, which is p of x is equal to 0. Given that p of x is equal to x minus 5, so we can write x minus 5 is equal to 0. That implies, let us transfer the minus 5 to right hand side. This gives x is equal to 0 plus 5, which is nothing but x is equal to 5. Therefore, x is equal to 5 is the zero of the given polynomial. Now, let us see the third bit, which is p of x is equal to 2x plus 5. In order to find the zero of the polynomial, we need to equate the given polynomial to 0, which is p of x is equal to 0. That gives 2x plus 5 is equal to 0, which gives 2x is equal to minus 5, which implies x is equal to minus 5 by 2, which is the zero of the polynomial. Moving on to the fourth bit, which is p of x is equal to 3x minus 2. So first let us equate the given polynomial p of x is equal to 3x minus 2 to 0. P of x is equal to 0. That implies 3x minus 2 is equal to 0. So transposing minus 2 to RHS, we get 3x is equal to 0 plus 2. That is 3x is equal to 2. That implies x is equal to 2 by 3. Therefore, x is equal to 2 by 3 is the required zero of the given polynomial. Now let us see the fifth bit, which is given as p of x is equal to 3 times x. Let us equate the given polynomial p of x to 0. We get p of x is equal to 3x is equal to 0, which gives 3x is equal to 0. That implies x is equal to 0 divided by 3, which is 0. Therefore, we can say that x is equal to 0 is the required 0 of the given polynomial. Now let us see the sixth bit, which is given as p of x is equal to ax provided a not equal to 0. So a is a number which is not equal to 0. So let us first equate the p of x is equal to 0, which gives a times x is equal to 0. Now we can judge that a is not equal to 0 because it is mentioned in the question. So x must be surely equal to 0 because a not equal to 0. Therefore, x is equal to 0 is the required 0 of the given polynomial p of x. Moving on to the seventh bit, which is given as p of x is equal to cx plus d. C is not equal to 0 and c comma d are real numbers. So first equate the given polynomial p of x is equal to 0. That gives cx plus d is equal to 0, which gives, transposing the plus d to right hand side, we get cx is equal to 0 minus d. That gives cx is equal to minus d. Transposing c to RHS, we get x is equal to minus d upon c. Therefore, x is equal to minus d by c, which is the 0 of the polynomial.